once again. In our last video, we learned the meaning of this, and we learned that this was just to calculate the change in functions. So the change in a function, if we change x by a little bit, and that it can be written like this: the change in f divided by the change in x. Today, we're going to actually do some sample problems of practicing exactly this to get us a better understanding of calculating the average change of a function. So the first example we're going to look at is, let's say we have a function f of x, which is x squared plus 5x minus 8. So that is our function, and we are being told that our initial value of x is 1. So we're just being told x starts at 1. And we want to know, how does this function change from x1? And we are told that the next step is x equals 1.2. So we are tasked with calculating, let me not put a dot there actually, period there. Just so you guys know, sometimes I end math expressions with a period, just like in writing English, you end a complete thought with a period. You see the same thing in mathematics. A period tells you that's the end of that expression. But I'm not going to put a period there because that 1.2 point, that kind of looks a little funny. So let me not do that. Actually, it looks a little funny here too, so let me leave those out. So the next step in our increment of x is 1.2. So we are tasked with calculating what is the average change in this function f if we change x, if we go from 1 to 1.2. How does this function change on average in between 1 and 1.2? So we're going to use this formula here that we looked at in our last video, and we're going to go through this. So let's just go ahead and plug things in. So first we have, what is the value of f at x naught plus delta x? Well, first let's just be clear, what is delta x? Well, we see that x has gone from 1 to 1.2. So how much did it change by? It changed by 0.2. So delta x is 0.2. Okay, now let's go ahead and plug things in. So we have f of our initial value plus that change, which is 0.2. So what is this? Well, really, this is just f of 1.2. And then this is f of 1. And what we want to look at is f of 1.2 minus f of 1. So let's go ahead and figure out, what is f of 1.2? Well, we're just going to plug 1.2 in everywhere that we see x. So we have 1.2 squared plus 5 times 1.2 minus 8. And so what is this? Let me move over this way. So f of 1.2 is, what's 1.2 squared? 1.44 plus 5 times 1.2, which is 6, minus 8. And what does that give us? 7.44 minus 8 is 0.56? Negative 0.56, right? Yes. Negative 0.56. Okay. Now we go back and plug in the initial value. So we figured this piece out. Now we got to figure this piece out. So what is f of x naught? Well, that's f of 1. And f of 1 means we plug in 1 everywhere that we see an x. So f of 1 is 1 squared plus 5 times 1 minus 8. That equals 1 plus 5, 6, minus 8, negative 2. Okay, So now let's go ahead and plug that into here. So f of x naught plus delta x minus f of x naught is, well, what did we get? F of x naught plus delta x was this whole expression here, which wound up being negative 0.56 minus a negative 2, which really means we add 2. And so what we get is negative 1.44. So that's the top half of this equation. Do I have another color? I do have another color. Might not even show up. So we found this. And then what is delta x? Well, again, we said that delta x was the difference between these two increments. So it's 0.2. So what we get is f of x naught plus delta x minus f of x naught, which this is the change in y, basically the change in this function, now divided by delta x is negative 1.44 divided by 0.2. And we get, what do we get? 7.2, negative 7.2. So there's our first problem. And I'm just looking through the book real quick, just to make sure everything is kosher and that everything is lining up the way that I want it to. Oh, you know what? I was wondering why this looked funny. This shouldn't be a negative. I was wondering why something just didn't quite feel right. Negative 0.56 plus 2 is positive 1.44, not negative 1.44. So 1.44 divided by 0.2 is 7.2. So what we are saying is this function here, we wanted to know what's the average amount that it changes by if we change x from 1 to 1.2, and we say that the average amount it changes by is 7.2. So on that interval, the function would change by 7.2. The output of this function would change by 7.2. All right, that's the first part of this practice problem. We're given a part B, which we're going to look at now as well. All right, now, in part B, we are told, let me take a look here, if x changes from 1 to 0.8. So we still have x naught, the initial value of x is 1, but now we want to say, instead of x going from 1 to 1.2, which was increasing, what if x decreases to 0.8? So meaning, what is delta x? Well, delta x is the difference between these two, and this changes by how much? Well, it's going down by 0.2. So now instead of a positive 0.2, we have that delta x, the change in x is a negative 0.2. X is going down now instead of going up. So we want to know the same thing. How does this change? If x goes from 1 to 0.8, we want to know how does this function change? And we're going to use this to calculate all of that. So let's start with this first piece, f of x naught plus delta x, which is, well, what is that? X naught is 1, delta x is negative 0.2. So 1 plus a negative 0.2 is a 0.8. So we want to know the function at the value of 0.8. And that's going to give us 0.8 squared plus 5 times 0.8 minus 8. And that is going to equal 0.64 plus 0.4 minus 8, which is, if I do a little math real quick, 0.68 minus 8 is 7 negative 7.32. No, it's not. I misplaced a decimal. So it's 1.04 minus 8, which is negative 6.96. Always double check your decimals, right? Now let's go back. Let's find the second piece, f of x naught, which is our function with x as a value of 1. So we plug in x, we plug in 1 for the value of x, and we get negative 2. 1 squared is 1, plus 5 times 1, which is 5, so 1 plus 5 is 6, minus 8, negative 2. All right, so we found that f of x naught plus delta x minus f of x naught is this minus this. It would be minus a negative, which is adding a positive. So it would be negative 4.96. So that's the top half of this formula here. And delta x, we already figured out was negative 0.02. So we have f of x naught plus delta x minus f of x naught divided by delta x is this, negative 4.96, divided by negative 0.2. And that gives us really don't like dividing by decimals sometimes. Gives us 49.6 divided by 2, which is 24.8. No, that's not right. Okay, let me back up. I am just going to do that over, and then I'm going to delete that portion of the video because I can do that. Okay, so let's go ahead and figure this out. So let's do this first piece. F of x naught plus delta x. Let's find out what that's going to be. So that's going to be the function f with a value of x naught plus our delta x, which is negative 0.02. So that means we need to find f at the value of 0.8. So f at 0.8 is 0.8 squared plus 5 times 0.8 minus 8. And that gives us 0.64 plus 5 times 0.8 is 0.4 minus 8. And we're going to do this. We're going to plug it into calculator just to make sure that we get it right. We get negative 3.36. Okay. You see a little bit of some erased marker here because actually my first time recording this video, I went through and I did this wrong because I did it in my head. I was off by a little bit on this decimal and it threw off the whole answer. So I had to go back and find where did I go wrong. Okay, so we have f of 0.8, which is this top part of this equation, the first part of this top part of the equation. Now, what's f of x naught? Well, that is f evaluated at x equals 1. So we plug 1 into everywhere that there's an x. We get 5 times 1. 1 squared plus 5 times 1 minus 8, which is negative 2. So we have 1 plus 5, 6, minus 8, negative 2. All right, now we can figure out what this entire top piece is. So f of x naught plus delta x minus f of x naught is this, which is negative 3.36 minus this, which gives us, because really this is adding a positive, negative 1.36. Okay, we have the top part of our formula. Now what's delta x? We already said it's negative 0.2. So the whole thing, f of x naught plus delta x minus f of x naught divided by delta x is negative 1.36 divided by negative 0.2. And that gives us like 6.8, I think. But let me plug it in just to make sure. So 1.36 divided by 0.2, yes, is 6.8. So what we are saying is that for this given function, if we change x from 1 to 0.8, f of x changes by this much. The average amount that f of x changes on this interval is 6.8. Okay. Let's do one more practice problem, and then we'll end this video. We'll probably do more practice problems even in the next video. All right, what's the next one? Okay. We're given a function, s equals 16t squared. And we are told to evaluate for t naught equals 3 and delta t equals 0.5. And we are told to find the average amount, the average rate of change of s when we change t starting at 3 and changing by this much. So that means the second value of t, let's say t1, because t0 is 3, t1 would be the next increment, which would be 3 plus the change in t would be 3.5. I'm just going to write that down. Okay, let's go ahead and start taking a look here. Now, sometimes this can throw students off. Sometimes it throws me off too. If we've memorized a certain formula or been working with a certain formula that's in f and x, and now suddenly we're given different kinds of variables like s and t, it can throw things off a little. But this is where pattern recognition becomes so important in math, is that when you practice and practice, you do it enough number of times, it doesn't matter what the variables are, you start to recognize the pattern. And that's ultimately something that we want to achieve. So let's evaluate the value of s at this first location. So we want to know s at t naught plus delta t. That is to say, we want to know s at 3.5. So our initial value 3 plus our change 3.5. So that would be 16 times 3.5 squared. 3.5 squared is 12.25. Again, I really should post that video about how to mentally square any number that ends in 5. Very useful. Okay, I'm going to let the calculator do this one. 16 times 12.25 is 196. All right, That's the first piece. Now let's get this second piece. S evaluated at t naught, so at our initial value of t, which is 3. So S of 3. So we plug in 3 here where t is. So that's 16 times 3 squared, which is 16 times 9, which is 144. Right? 90 plus 54, 144. Okay, so let's do this entire top piece, which is this minus this. So S t naught plus delta t minus S t naught is 196 minus 144, which is 52. All right. Now the bottom piece is just delta t. So S t naught plus delta t minus S of t naught divided by delta t is 52 divided by what was delta t is 3.5. Oh, sorry, 0.5. That would have definitely thrown off the answer by quite a bit. And dividing by half means you're just multiplying by 2. So we get 104. All right. We'll stop the video there. That's about 21 minutes. In the next video, we're going to continue doing more practice problems with this. This is like a warm-up to calculus. We're just learning, really this is the basis of all of calculus. Just understanding if we make a slight change to a variable that's in a function, how does that change the function itself? And that's what we're getting practice looking at. We're going to do more practice problems with that, and then we're going to actually jump into the underlying theorem of calculus, which is a slight modification of this. Technically, this is not calculus yet, but after we get a little more practice with this, then we're going to jump into how does calculus modify this and refine it, and that's when the real fun begins. I'll see you there.